No, exactly. No, this is not funny. You're using partial derivation. At the same time, it's for Jacobian. That's the process of What's the answer? Two tiny bars of y by x. Is equal to length, then bracket c squared. Like the length is like covering all those things. Like c squared is about a squared plus y squared. This thing. Yes, sir. No problem. What did you get? Why did you send it? That's the picture I used for you. We do the same thing. That was okay. Then plus half. Okay, my own, I think my minus on the x. So it's the same, we should get the same thing. How is the own minus? It's supposed to be minus stars.
You know there was minus. I took this one to the side. Like all of this is not the day plus
then why is it minus?
and shape minus.
Okay. I understand. So where do you go in plus return of function? Then y squared x squared. Right. But before. Yes. Where does it have minus? So that I brought it from side. I put the C inside. Makes me come and see. So it comes and C over the next. Then after to this. Then I brought this one. Yeah? No, this is in C minus the next. So you can come this over. That was my own intervention. Things say this way. Still the same thing, but the VH, but still the same thing. I don't think it was the same thing, I swear. But it's correct. Yours is correct. Yours is correct. I think mine is wrong. So just figure out.
Why did you minus?
I think mine was on the C on the X. And I put minus.
Okay. Let's solve it together and move to the next topic. Let's solve it together and move to the next topic. Can you all hear me? Sit down. Just have a seat. Let's solve it together and move to the next topic. Let's solve together and move to the next topic. Stop whatever you are doing or have done. Just look at me now. We are given this equation: x squared plus y squared equals c squared, and then you are asked to find the oblique trajectories. They are angle 45 degrees. Look at the board, please. Look at the board now. Stop whatever you are doing. Look at the board. So this is going to give us the derivative first. I'm going to have, now we differentiate this implicitly, 2x plus 2y y dx equal to 0. And from here, we get our y dx is equal to x over y. Is that correct? Everybody got that? Minus x over y. And then you are going to get, that means this is your M1, Abi? Yes. And then for you to get M2, which is the gradient of the oblique trajectory, you say that M2 is equal to M1 plus tan alpha all over 1 minus M1 tan alpha. And that is going to be minus x over y plus tan 45 degrees divided by 1 minus x over y multiplied by tan 45 degrees. Of course, you know that tan 45 degrees is 1, so you can just put that here. That's going to give you minus x over y plus 1 all over 1 plus x over y. Does it make sense? So this will give you the y, the x. So this defines the gradient of our oblique trajectories. Do you understand it up to this point? Okay. So we see that this is a homogeneous first order differential equation which you can solve by setting y equal to vx. That means that v is equal to y over x. Does that make sense? And then when you differentiate this equation with respect to x, I'm going to have the y dx is equal to, differentiate this as the product of two functions. That's going to be the derivative of this. You multiply by x, that's x, the v dx, plus v dx dx, that's 1. That will be plus v. Does it make sense? So we're going to substitute that into this equation. It will follow that our y dx is now x, the v, the x, then plus v is equal to, so instead of having x over y, I know x over y is 1 over v, Abi? So then I know that that is going to give me minus 1 over v, okay, plus 1, all over 1 plus 1 over v. So what will this give us? I'm going to have this to be x, the v, the x, plus v is equal to, so we try to simplify that. On the numerator, we are going to have this thing to be v into v minus 1. Does that make sense? And then on the denominator, we are going to have this v into v plus 1. Does that make sense? So this is going to give us v minus 1 over v plus 1. Is that clear? Okay, you get it up to this point, and then you can move that v to the other side. So let's write this out first. X should be the x plus v is equal to this. That means that x, the v, the x is equal to v minus 1 over v plus 1 and minus v. That's going to give us v plus 1 over, what will this give us now? We are going to move this to this side, that's v minus 1, then minus v into v plus 1. Does that make sense? Yes. So this is going to give us x, the v, the x is equal to v minus 1 minus v squared minus 1. Is that clear? Minus v. What's that? Minus 1. Thank you. Minus v. All over v plus 1. So our v, okay, will solve minus v. We are going to have x, the v, the x equal to minus into b squared plus 1 all over b plus 1. So you can now separate them, Abby. So this is going to give you minus b plus 1 all over b squared plus 1 db is equal to 1 over x dx. Does that make sense? Do you understand that? Yeah. Yes. So that's going to be what? Integral of this, integral of this. So for you to integrate this, you've come across something like this earlier now, Abby? Yes. So this is going to be minus, okay, you can put this here, integral of b over b squared plus 1 db, then plus integral of 1 over b squared plus 1 db. Does that make sense? Do you understand it? Then this is going to be integral of 1 over x, that's going to be mean x, is that clear? Plus c. Does it make sense? Alright, and then you can write that as mean x plus c so that you can put them together. Is that clear? This is going to give us what? This is going to give us minus integral of this is what? So you can write this as 1 over 2, then you put 2 here. So that the derivative of this is this. That would be 1 over 2 ln b squared plus 1 and plus the tan inverse of b. Is that clear? And then this is going to give us equal to ln cx. Does that make sense? Then you can simplify this further by bringing that to this side. You're going to have this expression. So you have minus here, Abby. I put the minus and then you bring them together. This is going to give you something like this. You're going to have this for the b squared plus 1. Okay, we can multiply 2 by 2 also when we do that. So let's just leave it as 1 over 2. Then plus the cx, then plus tan inverse of b. Is that clear? Because it's 0. Do you understand what I'm doing? Do you understand this? When you multiply 2 by minus, this will become minus. When you move it to this side, it becomes plus. That's what we have done here. Is that clear? When you multiply 2 by 2, now we are going to have ln b squared plus 1 okay, plus 2 ln cx plus 2 tan inverse of b is equal to 0. Is that clear? Yes. Then you can say that this is ln b squared plus 1 plus ln c squared x squared. Does that make sense? Okay, plus 2 tan inverse of b equal to 0. And then you can put this together and say this is the c squared x squared into b squared plus 1 plus 2 tan inverse of b is equal to 0. So this is going to give us what? So you can put back your v's now, Abby. Yes. Your v is what? Y over x. So this is going to be ln of c squared x squared into y squared over x squared plus 1 and plus 2 tan inverse of b. That's equal to 0. And this is going to give us what? Ln of c squared x squared. So this is going to be x squared, Abby, over y squared plus x squared. So this will become b. Then you have this left plus 2 tan inverse of b equals 0. And then this is going to give us ln of c squared into x squared plus y squared and plus 2 tan inverse of b equals 0. So that is that about that. Did you get it? Yeah. So we can move on to second order, homogeneous second order differential equations.
Solve everything.
Okay. They are very, 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 very simple.
I was about to transfer everything.
So ensure that you practice.
First time.
Yeah, exam.
Let's go, let's go.
SE. I thought it was one important course. No, by the time we are done, by the time you are done and they give you your transcript, they are just going to indicate whether you pass it or not.
Who never put GP news? The same thing.
Yes. Because of that C, you know that C
like it becomes minus, so the minus
it's better to put it this way anyway.
Yeah, true.
Anyway.
Don't worry.
One question, different answers. So all them are yes, minus I don't forget it. When I saw this,
so ensure that you solve all the other questions on this topic on your own as practice, and if you encounter any issue, just indicate on the group. So let's go on to homogeneous second order differential equations. It's quite short also to deal with, so not something difficult. Something you can easily revise in less than an hour. Can I clean this? Can I clean this?
Hey.
Sorry. As homogeneous second order differential equations with constant coefficients. Homogeneous second order differential equations with constant coefficients. So look at this now, look at this. So when we talk about, listen now, listen, can you hear me?
Yeah.
So look at this. Can you remember the definition for linear differential equations? Try to pull it down to a case of second order differential equations. We expect that we have a2 of x, okay, the square y, the x squared, plus a1 of x, the y, the x, plus a0 of x, y, equal to some f of x. Can you remember that?
Yeah.
Okay, this will be your, sorry, a0 of x, thank you. Okay, multiplied by y. So this is going to be your linear second order differential equation. Okay, this will be the general form of a linear second order differential equation. But in this case, we will be dealing with, listen please, listen. We will be dealing with second order differential equations. See, listen. We talk about linear differential equations we found. We say that a linear differential equation is homogeneous when f of x is 0. Are we together? So for a homogeneous second order differential equation as a linear, we're going to have this thing to be the square y, the x squared, plus a1 of x, the y, the x, the plus a0 of x, y, equals 0. This is what makes it homogeneous. Is that clear? The fact that you have 0 on the other side, that means every term here carries y or its derivative. Is that clear? And the coefficients are functions of x. Okay? And this is fine. But in this case, we will also simplify it further and look at cases where the coefficients are constant. Is that clear? That means instead of the coefficients carrying x, they will all be constant. Is that making sense? Yes. Alright, so when you have constant coefficients, that means you expect to have something like a, the square y the x squared, that's y prime prime, plus b, the y the x, that's y prime, plus c y to be equal to 0. So this is the general form of a, so what can you say about this differential equation now? It is linear, altogether, it is homogeneous, the second order differential equation, it has constant coefficients. Does that make sense? Alright, so this is the class of differential equation we want to deal with here. And we say that to solve these differential equations, generally, you will, there we go. To solve this kind of differential equations, we will usually make use of the substitution. We say that let y be equal to e raised to the power rx or mx altogether, and then when you do that and you get your y prime, what is y prime? If this is a solution, you can get our y prime to be what? R e raised to the power rx, and y prime will be what? R squared e raised to the power rx. So when we substitute all of this into this differential equation, we're going to get what? A into y prime, that's r squared e raised to the power rx, plus b into y prime, that's r e raised to the power rx, plus c into y, that's c e r raised to the power, e raised to the power rx, and everything will be equal to 0. Does it make sense? So from here you can extract e raised to the power rx. You can see e raised to the power rx is common to all of them. You have e raised to the power rx into a r squared plus b r plus c equal to 0. Does it make sense? So because this is always non-zero, we can divide it all through by this. So we are going to have this thing to be ar squared plus br plus c equals 0. And we usually call this the characteristic equation. The characteristic equation of the differential equation or auxiliary equation of this differential equation. So we will then solve this characteristic equation. Of course, for our second order situation, it's always a quadratic equation as expected. That means if we are dealing with a third order differential equation, it will be a what do you call that now? It will be an equation that has its power to be 3. And then if you are dealing with a fourth order differential equation, that means the power will also be 4. Is that clear? Then we're going to say it's going to be a cubic equation if you are dealing with a third order differential equation. Alright, so then we solve this we solve this characteristic equation. When we solve it, we will obtain two values of r altogether. You will obtain two values of r when you solve a quadratic equation. Is that correct? You will obtain two values of r when you solve a quadratic equation. Is that correct? Yeah. So depending on the form of this solution, you will have different forms for the general solution of this differential equation. So we said that we consider 3 cases here. So in summary, the first case is when you have real and distinct roots. Can you remember that? Yes. When you have real and distinct roots, that means that the two roots of this equation are real and they are different. When you have real and distinct roots, R1, R2, when you have real and distinct roots, R1 and R2, your y is going to be given by C1 e raised to the power R1x plus C2 e raised to the power R2x. Sorry. Yeah, R2x. So that's that. That's just going to be your solution to the second order differential equation. That means that once you obtain your for homogeneous case now, okay, it's quite straightforward to get. Once you obtain your auxiliary equation or characteristic equation and you find its root, then you are good to go. You will just get the general form of the solution. So when the roots are real and distinct, you will have this. And number 2 case, when you have the roots to be real and equal, that means you have repeated roots. Are we together? Okay, real and equal is another word for repeated roots. Okay, repeated roots. Okay, R1, so in this case, that means R1 is equal to R2, you can say it's equal to R. Is that clear? In that case, we have our general solution y to be given by C1x, okay, plus C2, then e raised to the power Rx. Is that clear? And then generally, when we have complex roots, can you remember? That's the third situation you can have. If you have complex roots, it is generally established that when you solve a quadratic equation and you get complex roots, the roots will be conjugates. Altogether, they will be complex conjugates. You know what I mean by conjugates? If one carries, so that means that if you have alpha plus I beta for one, the other one will definitely be alpha minus I beta. Does that make sense? from the fact that the square root, the root is always carrying plus or minus. So you are going to have complex conjugates. So when you have complex conjugates like this, we say that that's the third case. When you have complex roots, alpha plus, that's R1, equals to alpha plus I beta, and R2 equal to alpha minus I beta. So you're going to have your y to be what? Y. So this one will go to the power altogether, and then you're going to have this thing to be C1, C1 into sine beta x plus C2 into cos beta x. Then you have e raised to power alpha x. Does that make sense?
Yes, sir.
You understand this idea? Alright, so when you have complex roots, so the complex coefficient here is going to go to the sine and cos. Is that clear? And then you are going to have this power here for your exponent. So that's that about that. That's everything you need to know about homogeneous second order differential equations with constant coefficients. Okay? So let us solve some problems on these and see how to deal with it. So we call this the general solution. Okay, whenever you write this out, it's called the general solution. You may be asked to find a particular solution. Particular solution means that you want to get a solution for a given initial value problem. Initial value problem means that you'll be given the values of, let's say, y and y prime as some value of x, and then you use that to evaluate the constant C1 and C2. That's what I mean by a particular solution. If you want to get a particular solution, or if you are required to get a particular solution, you'll be given some initial conditions that will help you obtain the values of the arbitrary constant C1 and C2. Is that clear? Is that clear? So we can also call this, listen please, listen. You can also, this can also be called a two-parameter family of solutions. Two-parameter family of solutions in that you have two parameters, C1 and C2 here. Do you get that? Like what obtains for the first order differential equation where you have the one-parameter family of solutions, because you always have only one constant when you are dealing with the first order differential equation. Is that clear? Is this clear? Alright, so generally if you have an nth order differential equation, its general solution will contain n constants. Is that clear? That means that if you have a first order differential equation, its general solution will contain only one constant. If you have a second order differential equation, its general solution will contain two constants, just like we have it here, C1 and C2. And you can remember yesterday when we were changing a second order differential equation to first order to solve it, you know that in our final answer we had two constants. Now remember that we had C1 and C2 yesterday when we tried to reduce a second order differential equation to a first order differential equation. Alright, so let's solve the problems on these. I sent this to the group already. So open to the questions on this. So let's pick some of them and solve. It's quite easy and straightforward to get. I sent it to the group last week. Nothing has been added to it now. Yeah, 4. Yeah, 4. That's class 4. So look at it now. Let's get the first one. Find the general solution of the initial value problem. Okay. So that's quite confusing. The way it has been put is quite confusing. It shouldn't be general solution of the initial value problem. If you are getting general solution, you are not evaluating the constant C1 and C2. It should be a particular solution when you are dealing with initial value problems. Look at the board, please. So here you are given the equation y prime prime plus 5y prime plus 6y equals 3. So what do you think you are going to do here? Get your characteristic equation, or auxiliary equation. So that's quite straightforward. There's no need to say let y is equal to e raised to power. You know, this is OBJ, Abi. If you are dealing with a theory question, of course you should do that. But with OBJ question, there's no need to do all of that. Just change these parameters out together. So you just write this as what? R squared